guys, we'll try this for about the 5th time. My kids have bought me a new camera for Christmas from Banggood. It's a Firefly 8S, one of the GoPro clones, so I've been patiently learning how to drive it, and it's a little bit like a rabbit when I'm going through the settings, and the instructions aren't real clear, but I'm sort of getting the hang of it. I'm sure there's a lot more mistakes to come, but we'll see how we go for a first time anyway. Alright, when we finished up our last video, we talked about the motor adjustment, motor pivot, mount and adjustment. So we're going to start that in this series. So basically what we need is a methodology where we can pivot the motor and lock it off to set our tension on our timing belt. So there's two parts to this. There's the main pivot part and there's the adjustment part and the locking off part. So let's just have a look at the pivot part first. So we'll go into this plan elevation here. So it's made up of 3 parts. We've got 2 blocks that are both mounted into the slotter housing itself. Those blocks have a small spigot coming off them. And we have the main foot mount for the motor, which has 2 studs that allow the motor to be bolted down, and 2 reamed holes that fit up inside those 2 pivot blocks. So that allows us to pivot the motor. Around that pivot point. On the back side, we've got once again 2 pivot blocks that mount directly onto each foot, and in between that we have a pivot block which mounts to a stud through a clevis and then through the anchor shaft or anchor point that's mounted to the main bearing housing that supports the worm wheel. We might be able to get a better look at it on this view here. So there's that anchor. It's going to bolt into the bearing housing. We have a clevis which allows the stud to rotate in this axis, which is bolted through to another pivot plate which is mounted on these 2 blocks on either side. So as that goes up and down, the angle plate will then square up to the stud, and then we can lock that off. Once we've got our location, we can lock that off with 2 jam nuts. Might be able to see a little bit better inside here. So here we go here. So that's our foot mount. There's our pivot point there. We've got our studs going through, bolting up to our motor, and that's the pivot point there that motor will then rotate about. On the far side we have the block that we're going to bolt into the foot, and then we've got that other secondary pivot assembly that works between the 2 blocks, and then the anchor going down onto the main bearing housing for the worm wheel. Let's have a look at the details. So this is our motor foot base for our pivoting. This is going to be made out of a bit of 20mm thick stock, 20 by 50. It's 98 long, so we'll cut that back to the 43. I'm going to machine this out of the solid. You know, we could make this in various parts and fabricate and put it together, but I think it'll be a fairly interesting machining operation to do it as one part. Also got a little radius that we're going to cut in there with a tool. So as I said, I'm relearning my trade again, so it's been years since I've actually been on the tools, so these little projects are good for me to learn all those methods again. Right, so that's the motor foot mount. That's the block that we were talking about that we're going to mount onto the actual housing with the spigot coming out, which is going to mount up inside that hole there and allow that to pivot with the motor on it. Then on the other side we have our adjustment anchor, which is going to bolt into that bearing housing, and onto that we have our clevis that then mounts onto that anchor by the little pin. They're the 2 blocks that we've got for the foot mounts onto the motor, and then we have this pivot block here. with the two spigots coming off it that will mount into those blocks there, and then we'll have the stud coming up off that anchor up through here with two jam nuts on either side. So once again, this will be an interesting little machining operation, this one. So there's a fair bit of work in this little assembly. As I said, we'll make a start on that foot base first. So we'll go and head off to my favourite machine, the bandsaw, and we'll start cutting some stock up and then start laying down the process that we're going to machine this up. Alright guys, bear with me with this new camera while I get used to it, and we'll see you in a tick. Done. You might hear a lot of thunder at the moment. We've got a big storm coming in now. We've had 38 today. It's been very warm and uncomfortable. Yeah, that other Friday we tipped up to 45, and up in the northern part of the state we're close up towards 50, so that's getting very hot. So we've had some really stinkers this summer, but usually after a run of hot days we end up with these big summer thunderstorms come in and wash everything away and cool everything down. Anyway, we'll see what comes of that. Alright, we'll get inside and we'll start setting up to start machining off that bit of stock to make our motor mount foot. Alright guys, forgot to turn the thing on. We'll see how we go with the new camera. I'm still getting used to all the buttons I've got to press to get the thing going. I have purchased an external mic to go on this, so hopefully it'll take out a bit of the tinniness in the sounds. We'll see how it goes. But going back to what I just said, we're going to machine this all over, so it's going to be 43mm wide, 98mm long, and we'll take it down to the 18mm thick. So I'm just taking 1/2 mil off the top here, then we'll flip it over and get that down to thickness. I'm going to bore or drill in and ream the two pivot holes once I've got it all machined square, so I've got reference faces that I can go off. Then we'll machine the step in, and then we'll machine the foot flap to mount onto the motor, and we'll drill and tap and fit the studs to mount the motor on. All right, back to it again. Well, that was shocking. Yeah, those teeth are pretty blunt. I'm going to swap around the inserts to get to a clean cutting face, and we'll try that. Right, we'll see how that goes. I'm just going to do this cut because I am just dripping with sweat at the moment. That rain came through and the sun's come out, and it's stinking hot, and the humidity's just gone crazy. So let's make sure this is going to go. I'll just change the tips over. We'll give it a go and see if it's going to cut all right. Right, I know that was only a skim pass, but oh, geez, what a difference when you put new cutting edges in. I try and make these last for as long as I possibly can, because they're not cheap inserts. So just a home hobby shop. It's yeah, you just try and make them last as long as you can. All right, I want to go and sit in front of the air conditioner for a little while. It is stinking out here at the moment, absolutely dripping. So everything I touch is just going to get covered and rustabilio. So I'll pack it in for now, and we'll come back and start doing the edges, working off the fixed jaw all the time, and we'll get this squared up and down to size. Alright guys, we'll see you in a tick. We'll start machining these sides off now. A little bit all over the place, but we've got to take this down to 43, so we've got to knock about 7mm off it. So we'll take about 5 off this, maybe 4 off this side, and we'll flip it over, and we'll take the remaining off the other side. Alright, we'll take that out of the vise, deburr it, we'll flip it over, and we'll do the other edge, and we'll get that down to the, I'll say it was 47mm thick, I think, or might be 43mm thick. I'll go back and check my drawing. Alright, we're back in a tick when we get this set up. Get in your way a little bit here possibly, but yep, 18.15. So 0.15 to go there. I don't know if you can see that, but it's bang on 18. Alright. Get it out of there. Ooh. Sorry about that. But that is a beautiful finish on all edges. I'll deburr that, and we'll set up and we'll do these ends. But so far, so good. I'll just come out to start a little bit more, and yeah, the rain's just got pretty torrential, so yeah, it's coming down in sheets, so yeah, we might pack it in for the night. I think this isn't to stay. There's flooding everywhere at the moment. Yeah, joys of living in Oz. Alright guys, I'll see you when the weather's calmed down a little bit. Okay, there's probably a couple of ways that we can square those ends up. I could have set them down in the jaw and just used an end mill to machine them square, but I have to change the cutter out to do that. So probably the easiest way for what this is, I've just got that squared up with my square and just touched up the vise, nipped that up. That's going to be within a couple of thou, I reckon. Just tighten that up. Let me check it. Looks pretty good. And we'll check it obviously once we've done the cut. So I'm just going to take a very small lick off the top there just to clean it up. Right, we'll take the burrs off, we'll flip it over, and we'll machine that back to the length, which is 98mm. So I'm certainly missing the zoom function on my other camera, but we'll persevere with this one and see how it goes anyway. So I'll just nip that up very lightly. It's certainly been a very busy time in our household. Daniel started secondary school today, off to secondary college. So finished the primary school years and into what we call year 7, first year in secondary school. It's new high school, so you wonder where the years went. It seems like yesterday he was at kindergarten, and he's certainly grown up with his own little opinion and his own little thoughts on the world. Yeah, it's you wonder where the years go when they grow up like that. Right, we'll take this back, do a lick, and then I'll do a measurement, and we'll see how much we're going to take off.
What are you doing?
And here he is in his uniform.
What are you doing?
I thought I'd get a shot of you, mate. How are you? What's happening? I'll flick it off. What's going on, mate? 'cause we're aiming for 98. We're at 98.24. So 0.24 to come on. .98, so 0.02 off the 98. Right, I'll take that out. I mightn't take it out just yet. What we might do, I might deburr it. I'll leave it in here. I want to set up to do our pivot holes, so we'll do those next. Then we'll start the roughing out procedure once we've got those pivot holes in. Alright, so we've got sized faces here and lengths that we can now reference off to start putting our elements in. Right, we'll get set up for that drilling and reaming. Alright, getting ahead of myself here. Yeah, we're going to knock this this notch into it. Alright. Alright, can you pick what Mr. Muppet Man did? I was supposed to take this down, not that edge there. Long day at work and just not thinking. So guess what? I've got to start the block from scratch again. I think I'm going to sack myself here. Alright, well, yeah, we'll have to start again. Oh dear me. Alright. Righto, we'll take that out, get the burrs off it, and we'll set up for the next op. Alright guys, you can see that, that's how it's come up. That's our notches that we've put in either end. And as far as sizing goes, I'll just grab my calipers. So width we were aiming for I think was 43. Yeah, it's close enough. This one here I think was 68 across the flats there. Yeah, it's pretty close. What we need, 25 across here. It's pretty close. Once again, yeah, pretty close. And our thickness we were looking for was 18mm, and yeah, 18.02. Alright, so it's all well within about 0.02, 0.03, so it's nice to know that your machine's fairly accurate and can hold those sorts of tolerances. Right, the next job we're going to be doing is we're going to be having another go at putting our hole through. So as I said, I'm going to go to my mate's place and I'll grab a number drill. I'll let her drill whichever one it is, so that I can round that out 8mm. Once we've done that, we can then set up and start thinning out this section here for our motor mount. Once we've done that, we'll flip it over and we'll cut our little radius down through here, and we can drill and tap to fit our studs in place, and that'll be that one finished. Alright guys, we'll see you when we're set up for the next for this drilling show. Righto, so we're set up again. I'll center this, we'll drill it through with a 7.5mm drill. I've got a good mate of mine that's with a whole bunch of us catching up for afternoon tea today. So Johnny, he lives a fair ways out. He's going to bring in his letter N drill for me to finish this through so that I can ream it out. So I'll do that after I catch up with the boys. Alright, we'll get this basically done, and I can get this drilled out and give it back to Johnny before he goes home. Righto, so we've got the letter N drill. So another mate of mine, Ian, had one actually, so he's lent it to me. So I'll race home, I'll knock this over and I'll take it back and give it to him and catch up with the rest of the boys. Alright, we'll knock this through now. Yep, that's how we have. Right, we'll get this in the back gear. Slow it right down. Bit of go juice onto it. Let's see how we go. So this is a 5/16 one, as I said, it's about 2 thou shy, so I'm happy to use that. So dirty. Well, guess what, guys? That's just not what you want. Broken ream. I should have felt that was getting a little bit hard, and Yeah, paid the price, didn't I? Goodness me. Alright, we'll get out and we'll punch that out and see what we're going to do. Right, we'll set up and take the cuts off here. Yes, I've made sure I'm doing the right faces, so I've got to come down 5mm across 27mm. I'll rough it out with the carbide, then we'll swap it over for a high-speed steel end mill and finish it off with a nice finish. Right, we'll start roughing it out. Right, we'll just do the clean-up cuts with the high-speed steel. It's a 16mm. Right. Alright, all done. We'll get set up, we'll flip it over and we'll machine out the other face. Then we can drill and tap for our support studs for the motor feet. Righto, I've got a 25mm cutter in there, so I've put the bigger ER42 collet in. Got to come in 25 and down a total depth of 7 for this, so once again we'll do it with the carbides, rough it out and then swap over for the high speed steel to give the finish. Alright, we'll swap this out, we'll put a high speed cutter in and finish it out. Alright, done. Well, we'll just set up an edge finder now and we'll get an edge distances and we can get ready for drilling and tapping. Alright guys, we're going to put the radius on this back end here as per the drawing. Now, I have made a mistake in the design around the motor foot mount arrangement. So I'm going to have to make some decisions there on how we're going to go. That foot mount arrangement really determines how long that timing belt is, and I've purchased all of that gear at the moment. A couple of ways I can go about trying to fix the problem, but we might do a stop and prop. Once I've finished this, we'll go onto the screen and I'll show you what the issue is. And once again, it's assumptions that I've made that I should have checked out, but I didn't. So we'll go through and we'll have a look at a bit of the pickle that we're in at the moment with this. Alright, we'll get this done first. So this is a 6mm radius cutter. One more cut after this, I'm just cutting out radius. Right, we'll leave it at that. Let's go in the office. We'll load this up on the model up on the screen, and we'll have a look at the mistake that I've made. All right, we'll see you in a tick. Righto, guys. Let's have a look at this little problem that's popped up, which is going to be a bit of a pain to deal with. This is the component we've just manufactured. It's this motor foot, pivoting motor foot or motor base that we've got here. And we have the pivoting blocks on either side, and that allows that motor to then rotate about that center line. When we're designing, we don't design up the motors and the gearboxes and the cylinders and the bearing housings and all those proprietary items. We go to an OEM site or a third-party site like a Trace Parts, and we download those components to put into our design. And one of the things I'd always bang on about with my teams was whenever we get anything down off an OEM site or off the internet, we check it against the specifications. We make sure that everything is kosher before we go ahead and include that in a design, because the smallest difference in a dimension can really make a huge difference in a design, particularly if you're really cramped for envelope spaces and something's different when you actually get it on site to install it than what you've actually designed to, and it can create all sorts of headaches. So I've downloaded this, and one of the things I've done is I've got my motor specification charts that I pull up, and I go through all the dimension sets on here to make sure that what I'm looking at or what I'm designing to meets the specification. So on my model, I've downloaded my motor and I've done my shaft to center line checks of my first mounting hole. I've done front mounting hole to rear mounting hole centers. I've done the width centers. I've done from the underside of the foot to the center line of the motor. I've done the outside dimensional checks. So I've checked the entire motor right the way through to make sure that it meets specification. And this one does meet specification. The only difference is this measures up at 116 millimeters from outside of the foot to outside of the foot, and that measures up at 116. On the specification, that actually shows it as being 119, but for 3 millimeters, it's really nothing. It's 1.5 mils on either side, so I had compensation in there to allow for that. So that's what I've gone ahead and done based my design on. Now when I've got this little motor in, and it is a GD63, which is the frame size that meets that 0.18 kilowatt motor at 1440 RPM, well 1400 RPM, which is this bloke here. So it's a GD63, which is the frame size, and frame size is altered depending on the pole or the RPM of your motor. So I've done all my due diligence and checked that right through, and during the manufacture I've got my little foot here, and I've set that on my motor, and I thought, well, that doesn't look right. It's quite a bit different, and I'll take you down and show you what the issue is. Alright guys, let's have a bit of a look at what the issue is. So this motor from outside of the foot to the outside of the foot actually measures up at 138 millimeters. Quite a difference to the 116 or 119 as per specification. And that's going to cause me some real issues, the way that it's going to throw the motor right out. Everything else measures up okay. Hole centers measure up fine. Back to back measures up side fine. Shaft face to the first hole center measures up fine. Everything measures up fine except for this outside dimension. And in my design, that's pretty critical. Let's go back to the 2D drawings and we'll have a look at what that does to us. Alright, so here we are back on the CAD. So the issue we've got is from that face to that face. On each one is roughly 12 millimeters longer. So as you can see, that's pushing that foot right into that block assembly. The only other option I've got is to actually move the motor back out this way. The issue with doing that, and there's a number of problems here, is that it's going to lengthen the timing belt. These timing belts are fairly coarse in their size to size, from one size up to the next size. And I've selected this particular belt because it sort of suits the geometry and the way that everything's going to line up. By taking that out and doing the center to center check again, I actually lengthen the belt by 6 millimeters, which is a real problem. The other thing it's going to do too is it's going to throw this adjusting mechanism right out, so it's going to be sitting right up on an angle, and it's going to look, I don't think it's going to look shocking. I can pull these blocks back, but the symmetry of the whole design gets thrown out, and one thing I like about design is the symmetry. It's got to look right. So what am I going to do? I've had a look at these motor bows, these motor bases on here, and they're basically, as you'd expect, they're all very hollow, just with webbing on it. So trying to machine these, and I'm absolutely loath to machine OEM parts to modify into a design, because it just throws the next person out if they've got to go and organise spares, and you've modified that away from spec. They don't know about that, and it causes all sorts of issues. So I'm absolutely loath to try and modify bearing housings, motors, gearboxes, all sorts of mounts. I like to keep them as per their standard. The only way that I can see out of this is to actually unbolt the feet, because these are actually a bolt-on, and I suspect maybe that the feet that they've used on this may have been for the next frame size up, and that's why it's out. And I'm going to manufacture a new foot that fits within that envelope. I was trying with my little foot here to look at different ways that I could try and accommodate that, and I've actually machined in a little bit further onto that face there by another 3 millimeters. But then the pivot blocks are going to be in the way that sit up inside this envelope here are going to foul with the motor foot. So it's a bit disappointing. So off camera, I'm just going to manufacture up a new motor mount for this side. So going back to our CAD here, so as I said, they're bolt-on. When you get the Wegs and the Popes and the Comptons, they're usually in cast iron. They're actually cast up as part of the frame, but on this particular little Chinese motor, they're actually bolt-on. So I'm going to unbolt it, do a quick dimensional check on it, give myself a quick drawing, then I'm going to go away and manufacture up a new foot mount. The foot mount I've got is obviously it's solid all the way through. As I said, it just bolts into the frame of the motor. So when I got the motor, it was something I didn't look at. I'd done this design a long time before it actually ordered the motor and got it here. And maybe it's a bit of my fault. I should have maybe gone through and actually checked the motor to make sure that it was right. And I may have been able to do some, hindsight's a wonderful thing. Anyway, at the end of the day, it's caught me out, and I've got to look at a way that I'm going to fix it. And I think that's going to be the easiest way. Make up a new mount. Back on this one here where we smashed out the Reamer, I was able to go through with my 8mm hand Reamer after that, and that's come up as a beautiful finish. So don't put hand Reamers in under power in a drill or in a milling machine. You'll end up with the same result I did. So alright, well, we'll carry on with this. We'll make up the new foot and we'll get back on track with it. Once we've got that new foot in place, then I'll look at how we're going to go about doing this mounting on this side here and how that's going to look, and try and keep everything looking fairly symmetrical. Alright guys, we'll catch up with you soon.